welcome to Helicopter Adventures, the world's largest civilian helicopter training school. My name is Chloe.
And I'm Corey, and today we'll be walking you through a pre-flight of a Schwizer 300 CBI.
Along with Todd, our Director of Maintenance, we're going to be discussing some of the systems in brief, but it's only to give you an idea of how to pre-flight them. For more in-depth detail on how each system works, refer to the owner's manual or your instructor.
I would like you to keep in mind not to use this pre-flight video as a sole reference in order to pre-flight your aircraft. It should not be used as a substitute for a thorough pre-flight lesson with your authorized instructor.
Remember, as PIC of your aircraft, you are responsible for determining the airworthiness of the aircraft. If you ever have any question of the airworthiness of it, refer to the owner's manual or your maintenance department.
Hi, my name's Todd. I'm with Helicopter Adventures. I am the Director of Maintenance, and today I brought a few items with me to help us get a little bit better understanding of the inner workings of your aircraft and some of the things that you might see during a pre-flight inspection.
So, let's get started with the pre-flight of the aircraft now. The first thing you want to look at as you approach the aircraft is the stance. You want to make sure that it's level from both the side and from the front. While we're standing here, we can very easily check if there's any leaking fluid. This could be oil or fuel, and there shouldn't be any leaking under the aircraft.
Once we've checked the overall stance of the front crossbeam, we're going to move around to the other side of the aircraft, and we're going to check it from the side. We want to make sure, again, that we use caution for the tie downs, and we're looking across the stabilizers to make sure that there isn't any fore or aft tilt to them, and also side to side as well. You'd be able to see that by looking at the oleo dampers. This one looks good, so now we're going to move around to the back portion of the aircraft.
As we move to the back of the aircraft, we're again going to check the stance from here. What you'll be able to see is if anyone made a hard landing, there might be a bend to the aft crossbeam. So you're just going to kind of get down and have a good look at it, making sure that it's not got too much of a smile. This one looks fine. So we'll continue walking around the aircraft now and start our pre-flight.
So now that we've moved around to the right side of the aircraft, we're going to again check the overall stance, just like we did on the left side. Again, doing that just by crouching down, having a look, making sure the dampers seem to have the right amount of extension, and it doesn't appear that one is squashed down farther than the other.
Now that we've completed our initial walk around of the aircraft and checked the stance, we're going to go ahead and remove the tie downs. It's very important that you remove the main rotor cover first. That way, if you happen to rotate the blades as you're removing the other covers, you won't cause any binding or bending on the main rotor control rods.
As you see, I've removed the clips that are around these main rotor control rods first, and they actually say no hold, so that's very important not to grab onto those. The reason I'm removing the clips around the control rods was just like Chloe said, to prevent any possible binding. Now that I have all those free, I'll unclip the blades.
Now you'll notice that Corey is holding on to the aft mast support tube, and he has his feet here on the gray grip tape. It's really important that as you remove this cover, you only hold on to the aft mast support tube and keep your feet on the grip tape. If you were to place your feet anywhere else or to accidentally grab one of the control rods, you could seriously damage the aircraft. I'll take that. Thank you.
And the same thing when we get down. I'm only going to hold on to the aft mast support tube here, and there's a little ledge I can place my hand on if I need any further balance.
Next, what we're going to do is we're going to remove the individual tie downs off each blade. I'll go ahead and place this inside the cabin of the aircraft so it doesn't get blown around by any other aircraft that may taxi by. When you go to remove the tie downs, you first want to start down here by the skid. We're just going to go ahead and slide this one off. Now, in order to not put any undue strain on the blades, I'm actually going to untie all of the tie downs and then remove them from the blade tips. This will allow me to actually pull the blades towards me a little bit in order to slide that off carefully.
Now while Chloe's getting that side, I'll move back and I'll untie the aft tie down. As you can see, this one's properly tied down, and then it's wrapped around and tied along the top side. And as well, it also has the band going across the top of the main rotor blade.
Now that we've loosened the ties on all of the blades, I'm going to go ahead and just gently pull a little down on this blade here and remove the tie down from the top. You can see that if we had left the tie downs on the other blades first and tried to do that, we might cause a little extra strain. So now Corey can take the one off the tail if he would like.
Now as you bring the one off the tail, you'll notice that there's not very much clearance between these two. The reason we put these tie downs on, and it's very important to make sure that you secure them, whether it be downwash from another aircraft or just very strong winds, this blade could actually come down and impact the tail boom. So it's very important that we be careful when we're tying down and untying the aircraft.
Okay, now I'm going to remove the last cover off this blade. Once we've done this, it's very important that we rotate the blades around to the front of the aircraft. As you can see now, there's one over the tail, and as Corey said, we wouldn't want any blades sailing to possibly damage the tail or the blade.
One of the ways that we can do this is we can grab onto the tail rotor drive shaft here and just slowly rotate it in its counterclockwise rotation until we get that one blade over the front of the aircraft.
The aircraft should always be left in this position when the tie downs aren't on. This is even if you're only going to leave for a few minutes because someone may hover by or the wind may pick up. So make sure anytime you leave the aircraft, there's one blade over the front unless it's tied down.
Prior to every flight, we want to make sure that we have a nice clean windscreen. As you can see, this one looks relatively clean, but I'm going to demonstrate for you the proper way to clean the windscreen. So what I'll do here is just spray down the windscreen with our cleaning agent that we use. Come around to the side here, using some caution when you open the doors, not to damage or bend them. Once we've sprayed down the windscreen, we want to clean it nice and easy using the vertical motions here. The reason for the vertical motions is if you start to swirl around, you can actually create swirl marks in the windscreen, which can hinder your visibility in flight. One of the hazards that can be caused from that is, let's say you get a swirl motion in the windscreen and you're flying along and you can't tell if you've got just a blemish in the windscreen itself or a power line. That could be a hazard created from using the swirl technique. It's also very important to keep in mind, if you were to drop this rag that you're using to clean your windscreen, to go ahead and get a brand new rag. The reason for that is if you pick up any dirt or grime while you're cleaning the windscreen, you could very easily scratch up the windscreen or even put a gouge in the windscreen itself. Now that we've cleaned the outside of the windscreen, it's also important to check the inside of the window as well, as it may collect some dirt and dust as well. Now that we've finished removing all the tie downs, we're going to move inside to continue with our pre-flight.
We hope you enjoyed the pre-flight and learned quite a lot today. As we approach the aircraft from the front, we want to begin our inspection on the interior and then move to the clutch. What we'll do first is show you how to properly open and remove the doors. Then Corey will show you how to stow the doors, and later on we'll reinstall them. To open the door, we want to apply our thumb here and then use the latch by pulling our two fingers out. This way we don't damage the latch or the door. As we open the door, be sure to hold tight to it. Even a small gust of wind can pull it out of your hands and damage the door. While we have the door open, let's inspect it. While we're inspecting the door, we can also look at the proper way to open and close the vents. If you see here, we have a little metal ring that runs along the inside of the vent. What we want to do is put our fingers on top and below the little metal ring, apply a small amount of pressure, squeezing it, and then we can open the vent. Then release it. To close the vent, it's just the opposite. We want to squeeze the vent, pull it shut, and release. Again, we're carefully inspecting the seal on both of these. To remove our door, we want to keep firm grip on it, and we want to first release the wind stop here. What this does is if there was a gust of wind to catch the door and this was installed, it would hopefully stop the door from blowing wide open. Once that's released, we want to take our attaching pins and release both top and bottom. Now if Corey can take this and put it in the rack.
Now we're going to put the doorway into its respective rack. We want to use caution for the hinges, making sure that their hinges are down, and that as we slide them in, that they don't catch on any of the wood for the rack. So with our two hands, we're going to take the door, slide it in very slowly, using caution again, not to scratch the door on any of the tubes that are helping create these door racks. As we set it in, you can see that the hinges are on the downside and that they're away from any of the wood structure. And that's how you properly store a door.
Now that we've removed the door, we want to look at the interior of the aircraft. We're going to check for a few things in here. One of the most important things is the actual documents the aircraft has to have with it. We must check the pilot's flight manual, which is normally kept inside the glove box, which we have here. Inside this operation manual, we're going to find the weight and balance and performance sections. This is very important, and it must be on board in order for us to fly. We also need to verify that the registration and airworthiness certificates are in the aircraft and also for the correct aircraft. And you can see those here, and we want to just verify the N numbers. Once we make sure those documents are on board, we can look up at the top, and we want to check and make sure that the compass deviation card and the compass are both installed. I'm also going to check the outside air temperature probe and make sure that it's secure and there doesn't appear to be any leaks around it. That brings us to the panel where we're going to verify all switches are off and the mixture is pulled before we turn the battery on. So we'll just start at the top and we'll do a nice flow pattern. We're going to make sure every single switch is off in its off position. All circuit breakers are in, all the lights are off. Once we've done that, we know it's safe to turn on the battery. We'll turn the battery switch on, and once the battery switch is on, we want to make sure that we have sufficient fuel for our mission and that all of our warning and caution lights are operating correctly. We'll also test the horn for the rotor RPM if you're in a CBI or an aircraft equipped with a horn. We also want to make sure that all of the lights are working. To do that, we're going to turn on both the beacon and the position lights, and then we'll walk around the aircraft to make sure that they're all working and it's safe for flight. You won't want to leave them on during your entire inspection though, because it's very easy to kill the battery or to weaken the battery. So now I've moved outside the aircraft and I'm going to inspect the seat belts, the lights, and the clutch as well. What we can see is when we pull on the seat belt, you want to take it all the way out slowly at first and make sure that it's not twisted at all. This one looks fine. Once it goes back in, you want to give it a sharp pull to make sure that it'll catch in case you have to stop abruptly. This one works fine. As we continue our inspection down, you're going to check all of the threading, make sure none of it's coming loose, and that the seat belts where they latch, there isn't any fraying. And these do wear with age and have to be replaced periodically. This seat belt looks fine, and now I'd move over to the left side and check that one as well. Now we're going to go ahead and we'll turn the battery on and check the lights and the clutch. Once you've turned the battery on, we're going to check all of the lights and make sure that they're working. We can see the panel lights are working. We'll turn those off. Now you'd want to walk around the aircraft and make sure that both the position and the anti-collision lights are all operating properly. Once that's done, make sure you turn them off again so that you don't kill the battery. While you're standing here, you can also check the landing light. We're just going to turn that on briefly with a switch on the right cyclic. We can see the landing light works, so now we'll turn it back off. To check the clutch, we're going to engage it inside. The clutch has 3 switch positions: for release, which is at the bottom, hold in the middle, and then fully engage at the top. We'll engage that. You can hear now that the clutch actuator is working, so let me get in a better position to show you a few important things. As we're watching the clutch engage, you can see here the clutch actuator, and this is actually pulling tension on the cable, which will in turn tighten the spring. There's a couple important areas for us to check when we're looking at the tension in the belts. We can start at the top. We have 8 belts here, and we want to check the tension of each belt individually. If you find a belt that's extremely loose compared to the others, such as this one here, we want to check around back and see if it's actually tighter than the rest on this side, which is usually the case. If you do find a belt that is loose on all sides, it may be an indication that it's stretched or worn and should be replaced. What we'll want to do also is visually inspect all of the belts, looking for fraying or tears. Make sure you check the back side as well. All of these belts look good, but it's important to remember that if one belt is damaged, all 8 need to be replaced. We can then continue our inspection down, looking at the end caps of the idler pulley and looking for any wear or rust or burning. These look fine, and make sure you inspect the back as well. Everything's lined up and tensioned good. We'll continue our inspection, looking at safety pins or cotter pins on each of the bolts, and that brings us down to the spring. We have an alignment mark, which you can see here, and we want to have this black upper ring lined up with our alignment mark. If it's more than halfway off the alignment mark, it needs to be adjusted before we can fly. Now we're going to look at the pulley. Now the pulley here is a very vulnerable part of the whole clutch assembly because as you can see in this, you can see the screw here, all of the tension, which is about 235 pounds, is focused in that one point. So always make sure it's very secure and not cracked or loose. We'll also inspect the cable and make sure that all safety wires are in place. Once you've completed your inspection of the clutch, we want to disengage it and also turn off the battery. So what we'll do is we will put our clutch fully down to the disengage. While we're disengaging the clutch, you can watch the clutch actuator and make sure that the metal tube is not bent or binding at all. It should be a very smooth operation. Now the clutch is fully disengaged, and we want to turn off the battery.
After removing the tie downs and covers, we're now going to start with the pre-flight of the canopy portion of the aircraft. First thing that we're going to start looking at is we're going to look at the cross frames and the bonding that holds it together and also helps to seal it up. There's also rivets all the way along, and we're going to be checking the rivets as well to make sure that they're all in place, and these also have a type of bonding around them to help seal them up. We're checking the condition, making sure there's no cracks or pits and that none of the bonding has separated. We'll check that all the way along the cross frames and the vertical ones as well. As we check the vertical one, you notice that we come to what looks like a little piece of yarn. This is known as the trim string. What we want to do when we check this is we want to grasp the trim string and give it a slight tug to make sure that it's secure. When we check the trim string itself, we want the actual string to be anywhere from 2 to 3 inches long, and we want to make sure it's not too frayed. What you'll be looking for is separate strands. If there's more than 2 strands, then you'll need to bring that to maintenance's attention and they'll replace it with a new one. Now we're going to check the condition of the actual windscreen itself. What we're going to be looking for is any pits, scratches, or gouges that can obstruct our vision while we're in forward flight. So as we look along it, you can see up towards the top there's a little black tube that comes out, looks to be about 3 or 4 inches long. What that is that's the outside air temperature sun shield. And we want to pay additional attention to the area where that shield comes into contact with the windscreen, making sure that there's no cracks where it's connected or where the actual outside air temperature probe moves through. After checking that out, we follow down the windscreen and we come down to the bottom portion underneath the actual windscreen itself, and we're going to check the fairing. And you'll notice that there's a bunch of screws here. All these screws have a spring inside of them, so they're kind of a spring tension screw. And we want to make sure that these are all secure and pushed in properly. Now, since it has that spring to it, you may see them popped out a little bit. If you do, give it a little wiggle and make sure it's secure. And if you're unsure as to whether or not it's acceptable, ask your instructor. And if your instructor thinks that maintenance needs to have a look at it, then they'll get maintenance and they'll come out and check it out. As we're checking these screws, we're going to follow underneath the aircraft, and we're going to look at the induction system and the fairing portion. As we're looking for this, we're looking for any type of obstructions, anything that may have gotten blown into the air filter that could be obstructing the airflow in forward flight, and maybe a bird made a nest in there. So we want to check and make sure that it's clear. This is a CBI aircraft, so the airflow just goes straight through the induction system and right into the engine where it mixes with the fuel. On the CB aircraft, however, there's a carb heat door that we're going to check the general condition of the door, make sure it's not cracked or dented, and we're also going to check its connection points and make sure that all the screws are in and tightened. Next thing we're going to check is this antenna here. This is the VHF antenna for our radio frequencies when used to talk to air-to-air, other aircraft, and tower and ground control. What we're going to do here is we want to just check its overall condition, make sure that the antenna itself isn't bent, make sure that it's clean. We also want to check its security, and to do that, we're just going to use 2 fingers, grab onto it, and give it a little twist side to side. There should be little, if any, play. This one's secure. As you can see here, we've got a big red tag on this little tube here. It says remove before flight. What we're going to do here to remove this tag, this is on the pitot tube, and this is the pitot tube cover. What we'll do is we'll grab the pitot tube right at the little bend here, hold that firmly, and slowly twist off the remove before flight tag. The reason we need to have this off during flight is because the airflow comes in through the pitot tube, which runs the airspeed indicator. You want to be careful and never blow into the actual pitot tube itself because it's attached to some very sensitive equipment. What we want to check with the pitot tube is its security, make sure that it's stable. And to do that, we're going to grasp it with 2 fingers and give it a little twist side to side. There, again, should be little, if any, movement. Making sure there's no dents or any excess bends other than the obvious big one at the bottom. So it should be facing forward, and it should be a little upward motion to it as well. From there, we're going to move underneath. And you can see under the aircraft, it looks like we have a little shark fin. This is the actual transponder antenna, which is used for ATC purposes. What we're checking here is the security, making sure that it's not going to fall off in flight. And again, you can just grab that with 2 fingers and give it a slight pull to make sure that it's not loose and isn't going to fall off. And this one looks good. So what we'll do now is we'll continue our movement along the other side of the canopy. And again, we're going to check all the screws in the fairing and make sure they're all attached properly. We'll also check this side of the windscreen as well, making sure that there's no pits or dents or cracks or gouges in it as well. And we're also going to check the bonding, make sure that it's not separated, just as we did on the other side of the aircraft. From here, we're going to move over to the left side and check the door and attaching pins. Now, as we follow the bonding around to the left side of the aircraft, we're also going to check the rivets all the way up around the door frame again as well. We're checking just the same as what we did on the windscreen, making sure that they're all secure and none of them are missing. We also want to check the condition of the door frame itself, make sure there's no dents in the door frame, which would be brought to maintenance's attention because it may be a hazard for us in flight. We also want to check these screws and bolts here. What these do is they actually are used to attach the fire extinguisher, which is located inside the aircraft. We want to make sure they're secure and that none of the sealant around them has worn off. In the interest of safety, when you fly solo, you may want to consider leaving the left door on, since our tail rotor is on the left side, so it'll prevent any loose items that may be in the aircraft from flying into the tail rotor during flight. Next thing we're going to check is the pins that attach the door themselves, the door and attaching pins and the actual hinge. And what we're looking for here is we're checking to make sure that the hinge is secure, not cracked, and again that there's no dents. Making sure that the pins will move freely so that we can install the door and so that we can also take it off. We'll check the top one as well as the bottom one, the exact same as what we did with the top. Making sure again that it's secured, pins move freely, and nothing obstructs them. As we follow along the door frame, we're checking again, we've got some more rivets, and we're checking them just like we did on the other parts of the aircraft. Following up, we've got the door latch here, where the door actually connects and closes. We want to check its condition, make sure that it's not broken or bent that will hinder the door being closed or opened. As we follow up, you can see we've got a couple more rivets we're checking. Then we get up to this piece here. What this is known as is the upper canopy slat on the left side of the aircraft. And what it actually does is it helps to smooth out the airflow across the tail boom in forward flight. What we're concerned with here is to make sure that it's not cracked, which could create a hazard in flight if it were to break. So we're checking all along the different bends. We're also checking the security of the screws to make sure that the screws haven't started to crack the upper canopy slat as well. And this one looks good. And we'll continue with the rest of the door frame, checking the bonding all the way around the support braces. Now that we've finished with the pre-flight of the left side of the cabin, Chloe's going to come in and talk to you a little bit more about the landing gear.
Now, on first impression, the landing gear may appear to be relatively simple design, but actually it's very complex. It's designed to absorb the shocks during startup, shutdown, and also set down. What we can do is we're going to start first by looking at the general condition of the landing gear, We already checked the stance of the aircraft when we first came up and removed the covers, so now we're going to come down and have a closer look at some of the components. We're going to look at the skid itself. We're looking for any dents or bends. Perhaps there was a hard landing in the lesson before, so we just want to make sure that the skid tubes themselves aren't damaged. While we're down here, we can look over at the right skid tube and inspect the shoes. There are 3 skid shoes on each skid, which absorb the wear from surface taxiing and general set down. The skids themselves are very expensive, so for the skid shoes, we can just make sure that we have good clearance underneath and that they don't appear to be too worn. The ones on this helicopter are relatively new and look fine.
Here we have an example of your skid shoe, and the hard surface of the tarmac or runway. The skid itself, illustrated in yellow, is made of a very soft material and is easily damaged by the hard surface below it. Represented in black here are the skid shoes themselves, which are very hard and made of a much more durable material than the skids. The skid shoes should be the item that actually contacts the ground. The skid should not be touching the ground during a pre-flight inspection.
We also have on the aircraft 4 oleo dampers. Oleo dampers are the main shock absorbers of this helicopter during set down and startup. We can inspect several aspects of the oleo damper, and it's very important that we check each one individually. We want to check cotter pins on the bolts on both the top and the bottom, and we also want to make sure that the hydraulic fluid inside the oleo damper is not leaking. The way we do that is we grasp the rubber and kind of squeak it along the metal shaft inside. We want to make sure that it's not slippery or sticky at all. That sounds good. We also want to check the extension of each oleo damper. The way we can check the extension is by putting our hand between the upper and lower bushing and grasping the metal rod in between. We're looking for about equal extension on all 4 oleo dampers.
Here we have an oleo strut, also known as a landing gear damper. There are 4 of these installed on your aircraft, 2 aft, 2 forwards. The workings of the damper can be seen here because this one has had a cutaway. Again, this is an unserviceable part, so it's allowed us to make a training aid of it. Inside of the damper, when it's installed in the aircraft, this chamber would normally be full of aircraft hydraulic fluid, and this piston, which is hollow on the inside, would normally be full of nitrogen. This is a poppet assembly that allows the hydraulic fluid to transfer into the nitrogen chamber, causing your damper to give a cushion as it's compressed. At the top of the damper there is a wiper seal. This seal is responsible for keeping everything that needs to be inside, and dust and other foreign materials out. If this wiper seal fails, then you would notice a leak of hydraulic fluid and nitrogen along this sleeve right here. This sleeve is typically not accessible during a pre-flight inspection. It's covered by a dust boot. However, if there were a leak, you would be able to feel the hydraulic fluid beneath the dust boot when you did a pre-flight inspection. The front and rear dampers are serviced with different amounts of fluid and nitrogen, so the heavier portion of your aircraft, which is in the aft, has a higher charge than the forward portion of your aircraft. Anytime you go out to inspect, do a pre-flight inspection on your aircraft, should you find that one corner of your aircraft is sitting at a lower level than the other 3, then this is an item that you should pay particular attention to. It's quite possible that you have a leaking damper which has lost its charge.
So once we've finished inspecting the oleo damper, we can move along and look at the front crossbeam. We're looking for a smile because as we set down to land and the skids slide out a little bit, this can get bent, especially during hover auto rotations. We want to look in the middle and inspect it, making sure we don't have more than that inch. The aft crossbeam is more likely to bend, and there's a special method we use here to help see if we have more than an inch of smile. As we're coming along, we're going to look at the skid stabilizer. This is also how we step into the aircraft, and you can step on the rear portion as well to check the fuel level. We have here a drag brace. This is what gives us stability so when we set down that the skids don't collapse. We want to check cotter pins and make sure that it's not dented in any way. We'll check the bolts down here at the base as well and make sure that it's secure.
Here we have a drag brace, also known as a drag strut. There are two of these on your aircraft, and they extend from the forward crossbeam down to the rear skid support strut, also known as the hockey stick. These are responsible for keeping your aircraft landing gear in a level stance. As you can see, this one has a pretty pronounced bend in it. It should be straight. These are commonly bent during hover auto rotations, and additionally they are commonly bent by people actually stepping onto them while trying to climb into the aircraft. If you approach your aircraft to do a pre-flight inspection and find one of these struts bent, please bring it to the attention of the maintenance department prior to flight.
We have the skid stabilizer, and connected to that is the lights. We don't actually want to touch the lights. They may be hot if the aircraft just flew, and also we don't want to get any grease on them. So we'll just give them a little shake, make sure that they're secure and that this isn't loose. Be sure when you're stepping into the aircraft that you don't step on this portion. We have only a few small rivets, and it'd be very easy to bend or break this. As we're moving along to the rear of the landing gear, we now want to check this oleo damper. Same way we checked the first one. We're listening for the squeak and making sure we have good extension. We're checking the bolts at the top and the bottom for the cotter pins, and we're just making sure it's secure in general. This looks good. Now we want to talk about the way we check for the smile in the aft crossbeam. It's called the thumb method, and what you want to do is you put your thumb about halfway down, and then you sight along the crossbeam. You want to be sure that you can still see part of your thumb. If all you can see is the top of the crossbeam, then there might be too much smile, and you're going to want maintenance to come and inspect that. We also want to inspect, after looking for the smile, for any severe bending in the, around the cluster fittings here. What can happen is if you come down really hard on one side, you may have a gentle smile in the middle, but a very hard angle of bend here. So make sure you inspect on both sides of the cluster fitting.
Here we have a crossbeam assembly. On your aircraft, there are two crossbeam assemblies, a forward and an aft, this being the forward. This crossbeam assembly is one of the safety features of your aircraft. It's made of a softer material, so it is designed to yield in the event of a hard landing. As you can see down toward the end of this one, this is where the cluster fitting of your frame assembly would attach. And outside of this cluster fitting, we have a bend in this crossbeam. That's the reason this one was removed from service.
As far as the rest of the landing gear, it's basically a visual inspection of all the bolts, making sure that everything has its cotter pins and that there's no dents or problems. This brings us into the actual frame of the helicopter and what we call cluster fittings. We have 3 cluster fittings on each side and then one in the middle up there as well. And this is where the force from the helicopter is suspended on the landing gear. What we're looking for in a cluster fitting is that all the bolts are secure again and that there's no cracking of the paint or of the metal itself. We also want to visually inspect the upper one. You want to check all of the welds here for the bonding, making sure that the weld is secure. And then we can come around to the front and check this one as well. Visually inspect the one up inside also, just checking all the welds. And I think Corey's going to come in and talk about the engine left side now.
Now we've come to the part on the pre-flight where we're going to check and inspect the engine and the components. What we're going to do there is, as you can see, there's quite a lot of stuff that's happening in the engine at this point. First thing that I like to check out is I like to start and work my way from the back side of the engine first. One of the first things that we're going to check are the individual cylinders themselves. The rocker panel covers here, we're checking all the screws all the way around them to make sure that they're in and secure. There are a couple that you'll notice that have safety wire, and the reason for that safety wire is so it's an engine. Engines rattle, and you don't want these screws rattling loose on you in flight. That could create possibly a little bit of a problem for you. So that's the reason it's important to be checking the individual screws along both of these cylinders on this side of the engine. We'll do the same on the other side as well. Now we're going to be checking the spark plug access panel. What we're checking there is to make sure that all 4 of these screws are in and that they're tight. And again, just like the screws that we have here on the fairing, they are compression screws as well, so they have a little spring in them. You may notice a little bit of a gap, and that's all right as long as you can't pull it out. Again, if you have any question or doubt, it's always best to ask your instructor. Anytime you see a tie wrap on any piece of metal frame or tubing, you want to check to make sure that it's not cutting into any of the tubing or wires, as well as the metal framing or tubing itself. After checking the spark plug access panel, we're going to inspect the fuel lines and the brackets that are holding them in place. As the fuel line comes into the cylinder here, we just want to follow it and pay special attention to these brackets themselves. We want to make sure that the fuel lines aren't chafing and there's no sharp edges to the actual fuel lines. We have another one that goes into the cylinder here, and we also want to check that out as well. Follow them all the way back. We have a couple more attachment points that we also want to be checking back there. A couple little bends, and we also want to make sure that where they're attached, we don't see any actual bend in the fuel line itself, which could prohibit some of the fuel flow. You can also check the fuel line here as it comes down from the fuel tank itself. Check its overall condition, making sure that there's no fuel leaks and that all the fittings are tight. You shouldn't be able to twist any of them around with your hands. Making sure the actual fuel line again is not frayed, and check the connections as it comes into the electric boost pump on the CBIs. Again, making sure there's no fuel leaks at any of the attachment points. Then we follow it down to the actual fuel strainer itself, checking the condition of the fuel strainer, making sure it's secure, and again, no leaks. Now we're going to strain the fuel, and for that we need to maneuver our arm up and around these cross frames under the strainer here. We're going to position it so that the little knob that comes out of the strainer lines up with the groove in the strainer itself. That knob will sit right inside. In order to strain the fuel, push up and give a slight twist, and the fuel will start to strain into the strainer. Fill it about a quarter full, and that's all you need in order to check. And wait and make sure that all the fuel is drained out. Once you do that, you can remove the strainer, and we can hold it against the background of the aircraft here. And what we're checking now is for color, contaminants, and clarity, making sure that we have the blue coloration for the avgas, 100 low lead, checking to make sure that there's no contaminants such as dirt or any other sort of particles that may have gotten into the fuel, and also making sure that there's no water, which will show up as little white bubbles that will sink to the bottom. As you can see with this example here, we're showing you what contaminated fuel may look like. Now there's an abundant amount of water in this fuel, as you can see by the defined line between the white and the blue 100 low lead fuel that we're using. Water is heavier than the avgas, and that will fall to the bottom of the strainer that you're using. In most cases, if it's not this severe, what you can see is little white bubbles that will also drop to the bottom. What you want to do with this fuel is dispose of it in a proper manner set aside by each and every FBO. Now we're going to drain the fuel back into the fuel tank. For that, we're going to grab underneath the cap, twist it off. As we have the cap off, we can inspect the rubber grommet or seal underneath the cap to make sure that there's no cuts in it or any frays. We're also going to check the chain that's holding the cap in place to make sure that the chain is secure and there's nothing wrong with it. Now to drain the fuel back in, we want to put one finger on top of the little knob we used in order to strain the fuel. And when we pour the fuel back in, the reason we want to have that knob on the top there as we're pouring it in is so that it won't fall into the tank, and there's also a little screen that will stop any of the impurities that may have been in the fuel strainer or in the fuel itself from going back into the tank. Then we just re-secure the cap, and again, get underneath to twist it on and make sure it's tight. After putting the fuel back into the fuel tank after straining it, what we can do is a gentle tap test on the tank, listening for the difference in sound. This will give us a general idea as to where the fuel level is. So you can hear as the sound changes, indicating that our fuel line is somewhere around in here. We also would recommend doing a visual inspection by removing the cap and actually looking down inside the fuel tank. If you have the right amount of light, you can get a good idea as to the rough level of the fuel. On top of that, you also want to turn the battery on, and you want to check the fuel gauge indication as well. What we're going to also do is we're going to check the straps on the back side of the fuel tank, and we're going to make sure that they're secure, the nuts and the wires, make sure there's no fray or cuts in the rubber that's around it that could be cutting into the tank or, again, causing chafing or rubbing on the tank itself. Also up top here where these straps come in, there are bolts that secure them. And these bolts have been painted black so that you can see if the bolts have started to twist or spin. And to better check those, we're going to step up on the landing gear here, and we're going to use the grip tape in order to step up, making sure that we use caution around the beacon and position lights. So what we can do there is pull ourselves up, holding inside the door frame like so. And this gives me a better vantage point as to how it's secured through these straps. This time I can also look at the top where the breather line is coming through and see its general security and condition. What we can do now is move over to the oil, and we'll check the oil level. For that, we're going to need a rag. And to check the oil, we just need to twist off the dipstick cap and pull it out. It's quite a long dipstick, so don't be alarmed if it seems like you just keep on pulling. Now what we're checking here when we pull the dipstick out is we want to check the dipstick's general condition. We want to make sure that there's no frays in the wire whatsoever that could create a problem. As we put the dipstick back in, it may catch on something, and one of those frays may actually break off and get into the engine oil sump. So now that we've pulled the dipstick out, we can check the quantity down here. And the Schwizer operates anywhere from 6 to 8 quarts. And as a rule of thumb, operate right in the middle at 7 quarts. This one has approximately 7 quarts in it, so we're all good. As we put the dipstick back in, we want to put it in nice and smooth so that it doesn't create a bind as it's going back into the tube. That is where your frays will come from in the actual dipstick itself, making sure the cap is secure after we reinstall it. Now, if we were to need to add oil, we would want to wait approximately anywhere from 10 to 15 minutes before rechecking the oil so that the oil has time to flow all the way down through the tubes and into the oil sump. Now, you may have noticed that behind this filler cap, there's this little black box. Well, it's not the black box that they have in the airlines. This black box is actually a tensioner for our collective. And what that will do is as we raise the collective, you can actually see that spring's releasing, and that just gives us a little extra tension on the collective as we raise and lower it. So it makes it a little bit easier or harder depending on the condition of flight. Next thing we're going to do is we're going to check the exhaust. We're going to check its general condition. Now, this aircraft has been shut off for a while. If yours has just been flying, this is definitely not something that you want to touch. All you're doing is you're checking for its general condition, making sure there's no cracks or holes in the actual exhaust itself. And you're checking its security through the bolts here. Next thing we want to check is the spark plugs and the spark plug wires. We're checking the security of the wires, making sure the wires don't fray. And again, these are also connected right around the cylinder head covers, and we want to make sure that there's no fraying in the wires there as well. Both of these look good. And we're going to follow them back in, check the other connection points, and make sure we don't see any frays in the wires as well. Then we'll check out the intake manifold here and its general condition, making sure that it's secure. Check the oil lines as they run into each cylinder here. General condition, make sure there's no oil leaking outside of them. If there is, that again would be something to bring to your instructor's attention and possibly even to the maintenance department. Next thing that we're going to check is we're going to check the general condition underneath the engine itself. Right here we have the engine sump plug. What we're checking there is that the safety wire is intact and that there's no oil leaking below it or around it. This one seems to look good. No oil leaking and the safety wire is in place. We're going to move back and we're going to check the magneto, its security, and ensure that the bolts are there and that nothing's loose. At the same time, we're going to check the fuel servo and the rosette fitting, which is on top, or spider fitting. People like to call it a couple different things. I prefer to call it the rosette fitting. We're going to check its general condition back in there, make sure it's secure, and again, no leaks are coming out of there. From there, we can move to our alternate air inlet, which is back inside, and we're just going to give a little push on the door. You can hear it's opening and closing, and we're just making sure that if for some reason the induction system up front were to get clogged, that alternate air inlet would open up and we'd still be getting air into the engine.
Now we're going to continue our inspection. We're going to finish the back half of the engine and then move on to the shroud assembly and belts. When we come down here to the back portion of the engine, there's a few things we want to pay special attention to. We have the alternator here, and the alternator is connected by a bracket that's shaped a little bit like an L. It's very important that we check the bolt and that bracket for both their condition and to make sure they're not loose at all. We also have our alternator belt, and the correct way to check the tension of the alternator belt is to rotate it between your thumb and forefinger. We want to see that it will rotate 90 degrees, but not more, and if it does rotate a little bit more, just make sure that it's not really easy to do so. You can also grasp the alternator and just give it a little wiggle, not real hard, just making sure that again it's secure. We have the alternator breather line that runs to the back of the alternator and provides cooling, and we just want to make sure there's no holes or areas of leaking there. Okay, the alternator looks good on this aircraft and the tension is good. We're going to move back now to the shroud and fan assembly. This cooling shroud is made of fiberglass and is covered with paint. What we're looking for in here is any cracks. If you do see some cracking, inspect it carefully. If it's just the paint, then it's probably not a big deal and we're safe to fly. But if the crack is actually going through the fiberglass, we're going to want to have that inspected. We can then move inside to the fan itself. Inside here are 6 bolts, and they're all safety wired together. We're going to check the tension and the safety wire. We also want to inspect the fan, make sure it's free from any debris or grease. After inspecting the cooling shroud and bolts inside here, we want to come back and look at the H-frame bracket and the lower coupling drive shaft. The lower coupling drive shaft takes the power from the engine and transmits it to the tail rotor and to the main rotor. What we're going to be looking for here is any grease coming out of this boot. If there's any grease in this boot back here coming out of it, then they're going to need to replace it before we can fly. You also want to inspect very carefully for any red dust, which might indicate bearings rubbing or a problem like that. As we look around here, we're checking bolts, and you also want to look at the lower coupling drive shaft. What we're going to check here is we're going to rotate it back and forth, and what you're listening for is if there's a metal on metal noise. It should be full of grease, so you shouldn't hear any kind of ting. This one sounds fine. While you do that, you also want to see if this little sleeve here rotates freely or not. It's just held on by this bolt, and if the bolt isn't tight enough, this will actually rotate in your hand. It only takes them a few minutes to fix in maintenance. As we come back again, we're also going to be checking the security of all of these bolts and make sure that the H-frame bracket is not loose. We can also inspect the belts from this side, looking for any fraying and making sure that they all look in good condition. As you're continuing your inspection, you also want to look at the idler pulley from this angle and see if there's any red dust around the idler pulley. Before we continue our inspection of the tail boom and the tail boom supports, we want to set our alignment marks. The purpose of the alignment marks is so that we can inspect that the tail boom is straight here in the front and at the aft portion. Before we move the tail rotor or the main rotor, we always want to check for clearance, which I've already done. So I know it's safe to rotate the blades. Once the alignment marks are set, we will then check down at the tail rotor to make sure that the tail rotor drive shaft is actually straight and not twisted at all. As we start moving back now, we're going to inspect the tail boom supports, and we want to look at each one individually, checking the bolts for security. This also starts from when we checked the aft cluster before, and again we can just have a good look at that. As we're moving back along the tail boom, We're going to start inspecting it, looking for any dents or dings. And the easiest way to see this is to look down the tail boom and use the light from outside to show you any dents. We will also, as we walk back, run our hands along the tail boom, checking for any problems. As we move towards the rear of the aircraft, we're going to be inspecting the tail boom support strut. We're looking for any dents or possible damage to it. We also want to check the security of it at the top here, inspecting this bolt. You can see here there's these lines. One is the static line for the pitot-static system, and then there are two cables. One runs to the GPS antenna and one to the VOR antenna. We want to make sure that there is no blockage in the static line and that the cables for the antennas aren't frayed or torn in any way. We actually want to look under here and inspect the opening to the static port, making sure it's clear from any blockages. And this looks nice and clear. We'll also want to check that the GPS antenna is nice and secure and attached to the tail boom. So as we look at the exhaust, you can see that it's connected to the tail boom through a series of cables. These cables actually have two main functions. They provide a heat transfer to the air instead of the tail boom and also absorb vibrations from the exhaust during flight so that it's not transferred to the tail boom itself. As we move back along the tail boom, we're inspecting it again for any dents, and we're checking all of the rivets. We have this saddle here, which is connected to both tail boom support struts. This gives the tail boom added stability and also strength for all of the forces on it during flight. As we move our inspection back along the tail boom, we're going to inspect the VOR antenna. You want to make sure that both portions of the antenna are nice and clean. They can get a lot of dirt on them as we fly along, so if you have a clean rag with you, just go ahead and wipe those off. There's a coaxial cable inside here. Make sure that where it connects to the antenna itself is nice and secure. We are now at the vertical stabilizer, and we're going to inspect the vertical stabilizer's left side. What we're looking for here is that it's securely attached to the tail boom, and you can just kind of give it a little bit of a twist here, and all the rivets are secure. As we move back towards the tail rotor, we want to really spend a lot of time inspecting this. This is an integral part of the aircraft, and it has lots of small parts. As we come back to the tail rotor, the first thing we want to do is check our alignment marks. Earlier, when we rotated the tail rotor drive shaft to set the alignment marks at the front, now we can come back here and make sure the tail rotor is properly aligned. What we want to do is grasp onto the black metal. Make sure you don't actually use the stinger because it's possible to bend this or damage it. So we'll put one hand on the top of the stinger here at the black metal and another on top. We then want to pull down nice and smoothly and look inside the hole. Looking inside, you'll see one of two things. There's either a grease fitting or a small black line. The older models have a grease fitting that you can actually just reach your hand inside and feel. But if you see this is a CBI, and the CBIs, they just have a small black line inside. We now can return the tail boom to its normal position. We will know what's normal by simply lining up the stinger to a place on, say, your belt or your hip, and you can use that to be sure when you check the oil level that it's in the correct place. But we'll get into that in a minute. The first thing we want to inspect on the tail rotor itself are the blades. As you inspect the blades, we want to notice that the leading edge is steel and is fiberglass for the trailing edge. It's bonded right across here, so you'll inspect this for any pitting. We also want to look at the blades to see if there's any chips or dents along here from maybe striking an object in flight. If there is, definitely call it to the attention of your instructor. As we move up, you can see here, these are our attachment bushing bolts. You want to make sure that they're nice and secure. While you're looking at the bushing bolts, check this. This is a bonding area, and it's very likely to get pitted, and sometimes there's cracking. If you find any cracking, get your instructor or ask maintenance about it to find out if it's within limits for flight.
Here we have a tail rotor blade that has been removed from service due to a tail rotor strike. You can see a little bit of damage here on the tip end. And the reason I brought this blade today is because it's a good way to illustrate to you something that you might find on a pre-flight inspection. This blade is constructed of fiberglass and has a stainless steel leading edge with 4 rivets to hold the leading edge in place. If we come back around to this end, this area in the center here between the 2 wraps of fiberglass is only a filler area. It's very prone to cracking in the paint in the actual filler. And that's in fact what you see right here, is some cracking that has occurred. Now, this cracking in this filler should never extend beyond the corners of the fiberglass wrap, as this one does. If you find this cracking that moves around the forward 180 degrees of the blade, then that's a problem that definitely needs to be brought to the maintenance department's attention prior to your flight.
As we continue our inspection, you'll notice there's abrasion tape along here, and it's important that the abrasion tape isn't lifting on any of the corners, so we want to make sure we inspect that. We also have some teeter bearings, and these are just rubber bearings that help absorb forces as the blades flap. So we'll inspect each blade individually. You'll notice the small holes here. They allow pressure to equalize as we climb and ascend and as the blades rotate. We can now inspect this blade, and again we're looking for any cracks or dents, and we're checking the abrasion tape as well. The attachment bushing bolts look secure on both sides, and so do the pitch link connecting bolts. Now we'll move our inspection to the rear of the tail rotor gearbox. On the tail rotor gearbox, there's a few areas you want to pay special attention to. We have the pitch links, which allow the pitch of the blades to change. And you can see, as I move the control rod in and out, the pitch of the blades is changing. We have two dust boots that you want to make sure are secure and are safety wired on each end, and that all of the bolts have cotter pins going through them. While we're back here, we want to inspect the tail rotor transmission oil level, which is why it's so important to make sure that the tail boom is at the appropriate height. I know, and being my height, that if the stinger is at my belt, this is the correct height for the tail boom. We now have on the tail rotor transmission oil a sight glass, and you'll see that it says add full, and then it just has 269 aircraft, which is our aircraft type. The oil on this aircraft is just below the full line, and that's good. We then want to rotate the tail rotor blades, and as we're rotating, we're listening for any metal on metal noises inside this bearing. If you hear any metal on metal, it's important to notify your instructor and maintenance. As we move along this side, we have the tail rotor control rod, and again, we're going to move that back and forth, make sure it's not loose. We also have here the aft position light, make sure that it's secure, and make sure that all the wires running from it are secure as well. There are 4 bolts that actually attach the tail rotor gearbox to the tail boom, so check for security on those. As we inspect the tail rotor, we want to pay special attention to the tail rotor chip detector. The tail rotor chip detector is a circuit with a magnet, and if there's any metal chips or maybe metal on metal wearing, then the magnets will attract those chips and it will complete a circuit, allowing one of the warning caution lights in the cabin to come on, warning you of a possible tail rotor failure. You can see there's an orange cover to protect this circuit from any dirt or dust. So just make sure that the cover is on securely and that there doesn't appear to be any looseness, and it is safety wired. We have this stinger here, which adds protection for the tail rotor blades. And then you can see there's a little bit of a plastic pipe on the bottom, and that's just to help absorb forces and prevent the tail stinger from becoming damaged. Just make sure that it's nice and smooth underneath. We want to finish our inspection of the tail rotor and tail boom area by inspecting the horizontal stabilizer. When we inspect this, we're checking all of the bolts that connect it in place, and we also want to look for any dents. This is very thin metal here, and it's very easy to get a dent in it, so just take a good look at it. Once we are sure that the horizontal stabilizer is free of dents or any other problems, we're going to continue our inspection of the tail boom. As we come down on the tail boom right side, we want to check the right side of the vertical stabilizer. We're checking all of the rivets on this side and the aft portion as well. We'll continue our inspection of the tail boom, looking for dents or any problems. We can clean the VOR antenna on this side if we haven't done it already. And that brings us down here to the tail rotor drive shaft damper. The tail rotor drive shaft damper absorbs some of the forces of the tail rotor drive shaft inside the tail boom itself. The correct way to check this is we want to stick our finger inside and we want to feel for the damper. It feels like a little ring of metal wrapped around the tail rotor drive shaft. it should be able to move up and down and back and forth with a little bit of springiness. Okay, once we've inspected the tail rotor driveshaft damper, we're going to continue inspecting the rest of the tail boom. We can look at the tail boom support strut on the right side, checking all of the bolts. And the tail boom supports. We're going to be checking the cluster fitting here, checking all of the welds and the bolts, and then continuing our inspection of all of the other components of the tail rotor support system. You can see here we have these control cables. These actually run directly from the tail rotor pedals down to this bell crank and to the control rod and out to the tail rotor. It's very important that we inspect the length of these. When we're checking for fraying, it's important that you use a rag so that you don't cut your fingers. And look what somebody left here for us, a nice rag. So what we'll do is we'll take this rag and we're going to wrap it around the cable and just slowly slide it down. If you feel any tugging or like the rag is catching on something, go ahead and stop and visually inspect it. When we're inspecting the cables, make sure you check the entire length of them, and we can come down and also check some safety wires here, which help tension the cables. Okay, both cables look good in this instance. And now we can come back and we want to start checking around the lower pulley, the idler pulley, and the upper pulley. When inspecting the idler pulley, we're looking to see that there's a little play fore and aft, and that both end caps are secure and not showing any sign of wear. When we're checking the upper pulley, we want to look where the tail rotor drive shaft connects to it, and you can actually apply a little fore and aft motion. The tail rotor drive shaft should move a little bit, but not be making any metal on metal noise.
Here we have an upper pulley assembly. Inside of the upper pulley assembly is your sprag clutch. Your sprag clutch is responsible for allowing your aircraft to auto-rotate. And we'll talk a little bit about how the sprag clutch works. This is typically not something that you would see during a pre-flight inspection, but it is an item of great interest in the helicopter community. So I figured we'd take this opportunity to show you how it works. On a pre-flight inspection, you would see this upper pulley installed onto your main transmission input shaft. I've removed the caps from each side of this upper pulley to allow us to see the sprag bearing. If these caps were installed, what we would have was a sealed oil chamber inside those two caps surrounding the sprag bearing itself. Anytime during a pre-flight inspection, if you find oil on either this surface or this surface here, then that means one of these caps is leaking, and that's something that needs to be brought to the maintenance department's attention. The way this sprag bearing works is, as our belts want to rotate, our drive belts want to rotate this pulley in this direction, the interference fit of the sprag bearing forces the upper pulley hub to follow it. And you can see the splines inside the upper pulley hub where it mates to the main gearbox input pinion shaft. If we were to take this upper pulley hub and sprag bearing apart, you could actually see the sprag itself, the bearings themselves. Each one of these sprag bearings is shaped somewhat of a figure eight, and the distance from one corner to the other in one direction is smaller than across the other direction. So that's what allows you to have an interference fit. When the long side of these bearings rotate, they get wedged between the upper pulley inner race and the upper pulley outer race, and that's what gives the drive function of your aircraft. Additionally, if you enter an auto rotation to where your rotor speed is exceeding your engine RPM, these bearings rotate to the small side and allow this bearing to spin freely without binding the upper pulley hub and the upper pulley itself.
You can continue your inspection of the upper pulley by looking for safety wires and making sure that there's no grease. Okay, the upper pulley looks good in this instance, and we can continue our inspection of this side of the lower pulley. It's very important that, again, we check for grease or any red dust on the lower coupling drive shaft. Okay, both pulleys, all three pulleys in this instance, look like they're in good condition.
Now we're on to the mixer bell crank. And what we're checking here is we're checking all the different bolts that are in the entire area. What this does is it actually changes the pitch on each individual rotor blade or all of them collectively, hence the collective. So what we're doing is we're checking the blades for the main rotor control rods, which are right here. And there's 3 of them, 3 blades. So we're checking, we want to make sure that these swivel. The reason we're checking to make sure that each of the control rods swivel is so that if one were to get locked in place, if you were to apply force on it, it won't bend the control rod, which will reduce your controllability. So we're checking all the bolts, making sure that they're all tight. There's a cotter pin on each side. It's a safety pin, and we want to make sure that there's one in each of the bolts, each of the different nuts at the end. And we're also checking the paint around the nuts and bolts that go through the main rotor control rods to make sure that those haven't twisted as well. We're checking each individual one, as I said, and making sure that all are good. And around on the back side, you have another one that is back there, and that's actually a shorter version. And you're checking that one as well to make sure that it twists and that all the bolts are in and secure. And you can do that by feel, and you can also get on your tippy toes, and you can look down inside and make sure that everything is secure. We're also checking where the main rotor mast here is connected to the transmission, and we're checking all the bolts and making sure that there's no leaks around the connection points. And this one looks pretty good. I don't see any leaks whatsoever. Now what we're checking and what we're looking at here is an engine mount. What we're checking for is to make sure that the actual tube or mount itself is not bent or twisted. And we're also checking the nut and bolt that are coming through, making sure that it's not loose. And as you can see, they've also been painted around. So we're checking to make sure that we haven't seen any twisting of the nut itself. What we're going to be checking now is the aft mast support tube. We want to check its condition as it comes into a point down here, checking all the welds and its connection as well. We want to make sure there's no cracks in the welds whatsoever. We also want to follow it, make sure that it's not dented all the way up, that there's no dents or any bends in the aft mast support tube. It also has 2 other connecting points, one being right here on the right-hand side of the aircraft. You want to check both sides to make sure that the bolt and the nut are both secure and that they haven't started to rotate. We're also checking around all the connection points, making sure there's no bends in the bars themselves, and making sure that the welds have not broken. So we'll follow the tube down, making sure that it's not dented at all. And we'll also check its other connection point, which is down at the bottom of the cabin here. Again, there's one on the other side, the left side of the aircraft, in the same spot. And we want to check it just the same as we did the right. And those both look good. After checking those, we can check the fuel vent. We want to check the 2 nuts that we can see here, make sure that they haven't rotated or they're not loose. And one of the easier ways that we can check that is they've been painted. So if any of the paint is chipped away, that will let us know whether or not those bolts have started to twist. We also want to make sure that there's nothing obstructing the actual vent itself. If something obstructs this vent, what it can do is it can create a type of vacuum seal in the actual fuel tank, which will cut off the fuel flow to the engine, which will then create an engine failure for you. So it's very important to ensure that this vent is clear. Doesn't appear to be anything obstructing it. And we also want to check the actual vent itself. There's one bend in it, and that's all that we really want to see. Also want to give it a little twist to make sure that it's not loose. This one appears to be good. So after we climb up and check the main rotor mast, as we climb up, we'll be able to check the top side and ensure that everything's secure. Okay, so now that we've established that there are 3 main rotor blades, we're good to continue our climb up and inspect the rest of the main rotor head. The first thing that we're going to do is we're going to establish what points we need to hold on to in order to pull ourselves up. As you can see on the main rotor control rods, they say no hold on them. The reason for that is they're very sensitive parts, and as I stated earlier, if you bend them, it will reduce your controllability. So what we're going to grab onto is the aft mast support tube. The other place that we're going to step is on this tail boom support here. As you can see, it's got the gray grip tape on it, so that's going to be one of your footholds. There's also another one on the other side of the tail rotor drive shaft, which we want to avoid stepping on the actual tail rotor drive shaft itself. So we've got a handhold here, and then we're also going to put our foot up on the stabilizer for the skids as well. And there's also grip tape down there, so it will reduce your chances of slipping. Next thing we're going to do is just pull ourselves up. We can also place a hand here and hold on to give us a little extra support as we climb up. First thing that we're going to check, again, we're going to check the F-mast support tube. It's got a connector bolt, and we're also going to check around each of the welds that hold it on. This one looks good, so we'll continue with our inspection. Now we're going to have another look at the main rotor control rods. All three of them, their connection points, and to make sure that the bolts and nuts are in, and all the cotter pins are in as well. All three of these appear to be in good working order. So the next thing that we're going to check is this right here. This is known as a scissor link. What this does is it actually helps to connect the stationary swash plate here to the main rotor mast. So we're checking the connections here again as well, making sure everything's tight and that there's relatively little play side to side or laterally. This one all looks good. Now we're going to check the actual stationary swash plate itself and where it's connected here. And the connections look good, the bolts are in. There's also, you will find underneath each of the 3 points, there's another bolt that goes inside there. What the rotating swash plate does is it transfers the linear motion from the stationary control rods to the rotating motion in the rotating control rods. So what we're going to check here is you can see that on this swash plate, there's one side that has what looks to be a weight, and that's exactly what it is. It's a counterbalance to help with the balance and reduces vibrations that you'll feel in the aircraft due to the rotating parts. So the next things that we're going to be checking up here is we're going to check the rotating swash plates connection. And there's a series of nuts and bolts on top of it, and those are all painted. We're checking to make sure that those haven't twisted and everything looks good. Those all look good, so we're going to continue with our checks. Next thing that we're going to check is the main rotor pitch links. And what we're checking for here is that they can swivel side to side, just as we checked with the main rotor control rods. We're checking to make sure that there will be no binding forces that could actually damage the controllability. There's also a safety wire inside that's wrapped around these pitch links, and we want to make sure that the safety wire is installed and that none of the parts have twisted. We're also checking the connecting bolts, making sure that the bolt and the nut has the cotter pin in it or the safety pin, and that none of the paint has started to chip away, indicating that the bolt and nut may be twisting and coming loose possibly. Next thing that we're going to move to is we're actually going to check the main rotor blade itself, checking its general condition, and just by having a look along the edges here, making sure there's no chips or dings in the actual blade itself. This one looks good. Once we get down, we'll also visually check the underside of the rotor blades. Now to help me illustrate what the pitch links and the control rods do, I'm going to have Chloe come in and she's going to actually move the controls while I'm talking about the parts individually. I'm going to ensure that my hands are well clear of the controls, and you want to ensure that when you're out pre-flighting the aircraft that nobody moves the controls on you while you're doing your pre-flight. What could happen is you can get your fingers caught in any of the control surfaces and could possibly injure yourself. As you can see, as Chloe is moving the collective up and down, the way it's changing each of the control rods at the same amount, which is in turn changing the pitch on all 3 blades equally. Now as you can see, as she starts to move the cyclic, all 3 of the control rods are moving independently of each other, which is changing the pitch of each blade individually. And what that allows us to do is move forwards, backwards, and left and right. Next thing we're going to move to is going to be the elastomeric lead lag damper. And what that allows the blades to do is actually move back and forth. And we're checking to make sure, again, that these will swivel back and forth, again, to make sure there's no binding. There's also safety wire along these dampers, and we're checking the attaching pins and attaching points as well. They both have bolts and nuts, and we're checking to make sure that the safety pin is in there and that the paint has been chipped away, indicating that it may be twisting. There's also safety wire on the back side, and we're checking the back side connection to make sure that that safety wire is still intact. And we're also just checking the general condition of the damper itself to make sure that there's no signs of wear or cracking. This one looks good.
The main rotor lead lag damper is responsible for the lead lag of each one of your main rotor blades. It's an elastomeric damper, and this one, in particular one, is unserviceable, so we've made a cutaway to where you can see the inside of the damper. If you were to pre-flight this damper, typically what you would see is the turnbuckle and the root end that attaches to the blade. On this damper, this portion inside of here is actually elastomeric. So you would inspect this portion for cracks, any delamination along this surface and this surface. And additionally, this jam nut here, this center turnbuckle and this jam nut would be safety wired on a damper if it were installed on your aircraft.
Now we're going to move underneath, and we're going to check underneath the actual blades themselves, and we're going to be checking the droop stop. What the droop stop does for us is it allows the blades to actually stay hanging and not fall down and touch the ground. Now what we're going to do is we're going to lift up the blade. We don't need to require much force to lift this up, but we're going to lift the blade up a little bit, and underneath we're going to just wipe away a little bit of grease that's underneath there. Now we're going to visually inspect the droop stop, and we're checking to make sure that there's no cracking or any signs of wear. There's 3 different points for each blade, and we'll check all of those individually. This one looks good. After we're done checking the droop stop, the next thing we're going to check is going to be the flapping hinge. And the way that we do that is we just apply very gentle upward pressure on the main rotor blade, and we're checking to make sure that all of the blades are moving up and down independently. And it appears that they're all moving fine and that flapping hinge is working properly. We're also going to check this bolt here, the lead lag hinge. We're checking to make sure that the safety wire is in, and it's also painted. So we're checking to make sure that it hasn't started to unscrew itself. We're also checking all these other attachment points, the different nuts and bolts, making sure that there's no signs of wear underneath there, or that they've been spinning as well. We'll also check the top side. We'll check the top side of each one of these little bolts and make sure everything's good. Same with the drag hinge. All looks good. Now we're up to the top portion of the main rotor head. What we're looking at here is this big nut looking thing. What this is a hoist that the maintenance department uses to lift the helicopter up. They may need to do this for several reasons: engine change, weight and balance. It could be a number of different things. We're checking the security with the safety wire that they have up here, making sure that the safety wire is not frayed and that it's all secure. There's also some sealant that they have up here, and we want to make sure that there's no cracks or holes in the sealant that may allow moisture to seep in below this nut.
To complete our pre-flight of the right side of the helicopter, we need to take a look at the engine and landing gear on this side. When we come down, we will pre-flight this exactly like we pre-flighted the left side, with a few small changes. As you look at the engine, we can see the clutch actuator on this side. We're looking here at the cotter pins and just making sure they're secure. Be very careful, as it says on the side here, not to apply side load. It's very easy to bend or damage this. We will continue our inspection back. We have a voltage regulator, or alternator control unit, and what this does is helps the alternator produce the right amount of charge for the electrical system. We also want to inspect the battery and make sure not only is the battery itself secure, but also the cables leading to it as well. We can do this by just pushing on the battery a little bit, checking the top cover, and then checking the leads to the battery itself. Be careful as you're doing this to not get any battery fluid or any leakage from the battery on your hands. While inspecting the right side of the engine, we want to take a look at the crankcase breather line. This allows the engine to be vented, and we are expecting to see some oil at the bottom of it, but you don't want to see excessive amounts of oil leaking from it. When we inspect the engine on the side, we again want to check the spark plug access panel, making sure all the bolts are installed. Check the fuel lines and the rocker panel covers as well, again noting the safety wires and that all the bolts are secure. We'll check the security of the spark plugs. We also want to inspect the exhaust and intake manifold lines, just making sure that they're secure and there's not a lot of corrosion around the exhaust manifolds. As we continue our inspection of this side, we also want to inspect the landing gear, just as we did on the left-hand side. We're going to check the front and aft cross beams. We're going to check the oleo dampers the same way as we did before, and again verify that the lights are secure and not loose. We'll check the drag brace, looking again for any dents or problems, and we're checking for cotter pins on all the bolts. Continuing our inspection of the engine right side, we want to first check the security of the landing light. Now it's important to make sure not only is it not going to fall off, but also to make sure it's clean. So if only I had a rag. Here's one again. So we'll take our rag and we're just going to clean the landing light, making sure that it's very visible, especially on night flights. This is very important. As we begin our inspection of the main rotor transmission, we want to check the transmission oil level. You can see here we have a sight glass, and on the sight glass we have a fill line and a full line, and we want to make sure that the transmission oil level is above the fill line. Some of the older models that we have here at the airport will actually have a dipstick instead of the sight glass, and they've replaced the dipstick on the newer models because the seal was not very good, and in periods of heavy rain you could actually get water mixing with your transmission oil, which is not good. They also have tried to put a cover over the dipstick, and that helps somewhat, but the best thing so far is our sight glass here. And you can see that it's safety wired across the top. We can also inspect, while we're at this side of the aircraft, the cooling shroud on this side, looking for any cracks in the paint like we did on the left side. Next, we want to check the oil cooler, the oil filter, and all of the oil lines, making sure that there's no leaks and everything is secure. We can start at the bottom here. We're looking at all of the joints, ensuring they're safety wired and it's not leaking. You can expect a small amount of seepage down here, but there shouldn't be any drips. As we move up the oil line, we're checking for security, and we're checking that the oil filter itself has a safety wire running to the back. It should be tight, and there shouldn't be any oil leaking from any of the lines. Now we can follow these lines all the way into the engine. Just make sure that they're not fraying and they're not weak or bent or damaged in any way. We can see over here we have the starter itself, and you can just make sure that it's secure. And we also want to check the throttle linkage. To check the throttle linkage, we're going to come to this side of the aircraft, and we can just look inside here. What we want to do is make sure that the throttle linkage itself is secure and that all of the bolts have their safety pins in place. Okay. We can have Corey assist me. You'll see that as he rotates the throttle, the linkage itself is actually moving, and it's important that the movement is nice and smooth and that the rods aren't bent or catching on anything. While inspecting the right side of the engine, we want to make sure that the battery relay, the starter relay, and the landing light relay are all nice and secure. We want to check all of the wires and make sure that none of them are loose. We also want to inspect the oil drain, which you can see here underneath the engine. You can push up and rotate it and oil will leak out, so just make sure it's fully closed. As we continue our inspection, we're going to look at the solid state starter, which you may also hear referred to as a starter vibrator. Just make sure all of the wires are secure and that the unit itself isn't loose. Now that we've completed our inspection of the interior of the aircraft and everything else, Corey will help me reinstall the door. When we're reinstalling the door, to make it easier for you, before you start, just push the attaching pins down and hold them in their locked open position. This will allow you to place the door on and then snap them back. It's easiest if you hold the door from the inside, such as this, and then just line it up. Once it's lined up, you can move the attaching pins back into place, fix the wind stop if installed, and shut the door. When shutting the door, it's very important that you don't press on the plexiglass. It's very easy to damage, as I mentioned earlier. So to close the door and latch it correctly, it's just the opposite of opening the door. You're going to want to take the door latch, push it open, shut the door firmly, and then make sure it's shut and secure. Now that we've completed our pre-flight of the aircraft, you want to make sure that you tie it down properly. When we tie it down properly, it's exactly the opposite of the way you first remove the covers. We're going to go ahead and get them out of the helicopter now. Here you go.
Thank you.
Now, you may have noticed that this blade is very far above my head, and you're going to wonder, well, how am I going to reach that? Well, I'm going to show you a technique, but you want to be very careful not to bend the trim tabs, which are the small little balancing points on the blades where they adjust the trim of the aircraft for flight. I'm going to take my tie down like this, and I'm just going to toss it over the top of the blade, being careful not to have it wrapped around the trim tab. Then I can gently pull down on the blade, being careful not to put any strain on it, and grasp it just like that. I'll then take my tie down and slide it over the blade just like that. And Corey can do the same on the other side.
And those trim tabs that Chloe was talking about are located right here. And these are the ones that you want to be cautious of. So I'll move around to the front portion of the aircraft, and I'll get the blade that's over the front.
Now while Corey does that, I'm going to take the pitot tube cover, which I have here, and place it on top of the pitot. It's really important that we do this, especially in Florida where you get so much rain. If you were to get water in this tube, it could cause your internal equipment to not work correctly.
Now that we have two of the three blades on, we're going to move and rotate the blades the same way that we did when we took the covers off. We're going to use the tail rotor drive shaft in order to rotate the blade so that it's around the tail boom. Now as I do this, I'm being very careful to make sure that none of these ropes are getting actually caught on the skids themselves. We're rotating this around just enough to where you don't have to mess with the tail boom and possibly have that get in your way of looping around the tie down.
Now what you'll notice is when Corey puts this on, he's being sure that the actual ribbon that we tie around the blade itself is going to go across the top of the blade and then down. If you were to flip the tie down over, then it would actually cause the stitching to tear, and then the tie down would be ruined. Okay? Now that he's got that in position, we want to first go ahead and put the front blade tie downs on the skids. The reason we do this first is that one is adjustable and these aren't quite as adjustable. So this way, we'll know exactly how tight to tie that rear one. You can see I'm just sliding it over the skid tube here, down past the first bolt of the skid shoe. This will ensure that it doesn't come off. And I'm going to do the same for the other side. Okay, now that those are secure, Corey can tie down the rear of the blade.
As you notice, or may notice, this blade is definitely a lot higher above my head than what it was before when I previously put on the tie down. That's one of the reasons we like to do the front skids first. So what we're going to do there is we're going to take the two straps, we're going to pull them around the tail boom like so, being careful not to apply too much pressure on the actual main rotor blades themselves. Loop it around like so, and just give it a little knot at the top.
Now it's very important that you do exactly what Corey did here, and you'll notice that he's tied it in front of the vertical stabilizer. If you tie it behind the vertical stabilizer, wind can actually blow off the tie down, and then it's useless. Also, if you tie it on the vertical stabilizer at some point along here, because of the angle and how smooth this is, it can actually work itself loose. So very important that you tie it just in front of the vertical stabilizer.
Now the thing we have last to do is the main rotor head cover.
Now watch as Corey climbs up. Again, you're going to see the correct demonstration of how to climb up onto the aircraft. Being very careful at all times of where you put your hands and to keep your balance. He's grasping onto the aft mast support tube and placing his feet on the gray grip tape there.
Now the first thing I'm going to do is secure the clips around the main rotor blades. As you'll notice, this part is fairly thin, and the parts that go over the blades are a lot wider. So remember, you want to have the wide part of the actual tie down over the blades. Another reason for doing this is it'll help you adjust so that you don't put too much pressure on the main rotor control rods. Now that I've got all the blades secure, I'm going to start with the side clasps, being careful not to put any pressure or even grab on to the main rotor control rods.
One thing you'll notice is that you can make all the clips go around the outside of the main rotor control rods. But if that feels a bit too tight, like you're afraid you may be putting strain on them, you can always do one set of clips inside the control rods, and this will stop any pressure from being applied to them.
This one fits pretty well.
Thank you for watching the video today. I hope that it will be useful in helping you develop a good pre-flight technique. Never underestimate the significance of a good, thorough pre-flight inspection. It is a very important part of the maintenance that is necessary to keep an aircraft flying safely. Although Corey and Chloe have done a terrific job of identifying key areas of interest, remember that it would be impossible for us to demonstrate every scenario that you may encounter. Because of this, you must develop your own pre-flight sequence, which ensures that each system and portion of the aircraft has been thoroughly examined prior to climbing in and buckling up. This might seem a bit overwhelming at first, but I assure you that it will become easier as you progress through your training and become more familiar with the aircraft. Should you ever encounter an item or condition that you are uncertain of, please ask for the assistance of your maintenance department. We take the safety of our students, instructors, and aircraft very seriously, and will always be willing to help you resolve any uncertainties that you might have. Remember, as PIC, you are ultimately responsible for ensuring that the aircraft you are operating is in an airworthy condition. Good luck with your training, and I hope that your experience here with us is a positive one.
Now that we've put on all the tie downs, I'd like to thank you for watching our pre-flight video.
Now remember, this is only to give you information regarding how to pre-flight the aircraft. It's not meant as a substitute for correct lessons or for the owner's manual itself. If you ever have any questions, contact your maintenance department or refer to the owner's manual. Have a good day.